So what exactly is a reverse proxy? Think of it as a middleman for web request. Instead of a client like your web browser directly connecting to a backend server, the reverse proxy steps in to handle that connection. Now, why would we need this middleman? Reverse proxies serve several key purposes that make them invaluable in backend engineering. First, they help balance the load across multiple servers. Imagine hundreds or thousands of users accessing the same website at the same point of time. Without a reverse proxy, all of those requests might... Hey everyone, welcome back to Prep Train, the channel where we dive into all things tech, backend engineering, and help you lever your skills with practical tips and insights. If you are new here, I am Sai Kumar, and today we have got a really exciting topic lined up just for you. So let me ask you this. Have you ever wondered how companies like Netflix or Instagram manage to serve millions of users all while keeping their platforms fast, secure, and seamless? Well, today we are going to uncover the tool that helps make that possible, reverse proxies. It might sound technical, but trust me, by the end of this video, you will understand why reverse proxies are one of the most important elements in backend engineering. We will walk through the basics, explore how reverse proxies handle load balancing, enhance security, and improve performance. And of course, I will show you some real-world examples to make it all click. Before we get started, if you haven't already, make sure to subscribe to Prep Train and turn on notifications so that you don't miss any valuable content. We have got a lot of practical insights coming up that you don't want to miss. Also, if you are looking for latest job and internship updates, or you want to connect with other in this field, join our Prep Train Telegram community. It's the perfect place to stay informed and network with like-minded learners and professionals. All right, so let me just grab my deck and then we will continue diving deeper into reverse proxies. Alright, so what exactly is a reverse proxy? Think of it as a middleman for web request. Instead of a client like your web browser directly connecting to a backend server, the reverse proxy steps in to handle that connection. When you refresh a website or request data from an app, your request first goes to the reverse proxy, which then forwards it to the appropriate backend server to get the data that you need. Now, why would we need this middleman? Reverse proxies serve several key purposes that make them invaluable in backend engineering. First, they help balance the load across multiple servers. Imagine hundreds or thousands of users accessing the same website at the same point of time. Without a reverse proxy, all of those requests might overwhelm a single server, causing slowdown or even failure. The reverse proxy distributes these requests evenly across multiple servers, ensuring that no single server gets overloaded. Second, reverse proxy basically enhances security. They can hide the identity of your backend server from the public internet, which is crucial in protecting your infrastructure from direct attacks. This is especially useful in defending against, distributed denial of service attacks or DDoS attacks, where attackers basically flood your servers with so many requests that servers become unavailable. Lastly, reverse proxies can also improve performance by caching. This means they can store copies of frequently requested data, such as web pages, and serve them directly to the users without bothering the backend servers. This not only speeds up response time, but also reduces the load on your servers, making the whole system more efficient. To sum up, reverse proxies act as intermediary between clients and server, helping them with load balancing, security, and caching. They are critical for seamless functioning of large-scale and web application like Netflix and Instagram. Alright, now that we have a basic understanding of what reverse proxies are, let's move on to a real-world example to make this even more clear. Let's simplify things with a real-world example. Imagine that you are at a restaurant. When you are hungry, you don't go directly to the kitchen to place your order, right? Instead, you communicate with the waiter. The waiter takes your order, passes it to the kitchen, and then brings your food back to you. The waiter basically handles the back and forth between you and the kitchen, so you don't have to worry about what's happening behind the scene. In this same example, the waiter basically represents a reverse proxy. You, the customer, are the client, and the kitchen basically represents the backend server. The reverse proxy or waiter basically takes your request, ensures that it gets to the right backend server, or let's say safe, and then brings the response back to you, all without needing to know what's happening behind the scene in the kitchen. This is very similar to how web applications work. When you make a request to load a web page, it's like placing an order at a restaurant. The reverse proxy ensures that your order basically reaches the right backend server efficiently and securely. And just like a waiter can help manage a busy restaurant by distributing order to different safes, reverse proxies basically help balance incoming client requests among multiple servers, ensuring that no single server is overwhelmed. On top of that, just like how a good waiter might remember your favorite dish or drink or starter and bring it to you faster the next time, a reverse proxy can cache basically frequently requested data, allowing it to serve you faster without asking the backend server again. So the reverse proxy is much more than just a middleman. It's an essential tool for optimizing performances and security in modern web application. Now that we have covered this example, let's move on to the superpowers that make reverse proxy even more impressive. Okay, now that we have introduced you that what a reverse proxy is and how it works, let's dive into the superpowers that make it such a crucial tool in backend engineering. The first superpower of a reverse proxy is load balancing. So imagine basically you are running a popular website with millions of visitors. Naturally, you don't want all of those requests to just hit one server, right? If that happens, the server might get overload, slow down, or even crash. So your site will go down. So instead, a reverse proxy basically acts as the traffic police or traffic cop, and it distributes the request evenly across multiple backend servers. This ensures that no single server becomes overwhelmed and that your website continues to run smoothly, even under heavy traffic. It's like having multiple chefs in the kitchen, and the reverse proxy decides which one is less busy and forward the order to them. The second superpower is security. A reverse proxy can protect your backend server from directly exposure to the internet. This is critical for preventing attacks, especially DDoS attacks, which I said earlier, distributed denial of service attacks. So here malicious users flood your servers with thousands of fake requests trying to overwhelm or crash your system. So by acting as a shield, the reverse proxy basically absorb these attacks and prevent them from reaching your backend infrastructure. Think of it like a bodyguard that stands between your servers and the outside world, filtering and managing all incoming requests before they reach their destination. The third superpower is caching. So reverse proxy can store copies of frequently requested data such as web pages or media files. This means that whenever multiple users request the same content, the reverse proxy can basically serve it from its own cache rather than bothering the backend server for the same data repeatedly. This not only speeds up response time for user but also reduces the load on the server, making your application more efficient. So to summarize, reverse proxies are more than just intermediary between client and server. They bring powerful features like load balancing, security, and caching to the table, and it ensures that web applications are fast, reliable, and secure. Next, we will break down some key components and terminologies that you will encounter when you will be dealing with reverse proxies. Okay, so now that we understand the basic superpowers of reverse proxy, let's break down some of the key components and terms that you need to know when you are working with them. First up, we have the client. In basic terms, the client is basically the user or device that's making a request to the server. For example, when you open your browser and type in a website or a URL, your browser basically acts as a client. It sends a request to the server or to basically load the web page, and client can be anything from web browser to mobile apps or even Internet of Things or IoT devices. Next, we have the backend server. These are the machine responsible for processing the request made by the client. They store the data, they process it, and they generate the content that gets sent back to the client. Backend server basically handles tasks like database queries, file storage, and running application logic. They are the heavy lifter of the system, and without them, nothing would function. Then we have the load balancer. So basically, as we mentioned earlier, this is a type of reverse proxy that helps distribute incoming traffic requests across multiple backend servers. The purpose of a load balancer is to ensure that no single server is doing all the work while others are sitting idle. It helps prevent overload and keeps the system running efficiently. And think of it basically as a traffic police, maintaining that all requests are speed across all the available servers. Finally, there is SSL termination. SSL or secure sockets layer is basically a protocol which is used to encrypt data between the client and the server. So you have probably noticed that secure websites start with HTTPS instead of HTTP. That is SSL at work. SSL termination is the process where reverse proxy basically decrypts the data before forwarding it to the backend server. This offloads the computational work of encryption from the backend server, freeing them up to handle more requests. Each of these components plays a critical role in making sure that reverse proxies can do their job efficiently and securely. Next, let's take a closer look at the difference between forward and reverse proxy and why reverse proxies are more commonly used in backend systems. All right. So at this point, it's important to identify the difference between forward proxy and reverse proxy, as they serve different purpose, even though they sound similar. So let's start with the forward proxy. Basically, a forward proxy acts on the behalf of client. So think of it as a middleman between the client and the internet. For example, if you want to access a website but don't want the website to know your IP address, you can use a forward proxy. The proxy will make the request on your behalf, fetch the content from the web, and then send it back to you. So in essence, it hides the identity of client from the server. Forward proxy are often used by clients to avoid geo restriction or to browse the web anonymously, basically VPN. On the other hand, a reverse proxy act on the behalf of server. So instead of hiding the client identity, it hides the identity of backend server. This reverse proxy sits between the client and the backend server, and it manages the incoming request on behalf of the server. It handles tasks like load balancing, caching, and security, and the client does not need to know which backend server is responding or even how many servers there are. All of that is basically managed by the reverse proxy. In backend systems, reverse proxies are more commonly used because they allow company to scale their services and protect their servers and also distribute the traffic efficiently. When you are managing a large application, let's say Netflix or Instagram, you don't want clients directly accessing your backend server. Instead, you just want a reverse proxy to sit between the client and the server, and it handles all the requests and ensure that everything runs smoothly. So to summarize, forward proxy are used by clients to access content on the internet anonymously, while reverse proxies are used by servers to manage clients' requests efficiently and securely. Next, let's wrap and explore some real world use cases of reverse proxy to see how they are applied in major web services. All right. So now that we have covered the basic of reverse proxy, let's take a close look at some real world use cases where reverse proxies are vital in handling massive amount of traffic and ensuring that smooth, secure, and reliable operations are done. The first example is Netflix, let's say, and think about how many people are streaming movies and TV shows at any given moment. Netflix basically uses reverse proxy to balance the load across many of its servers. When you hit play on your favorite show, a reverse proxy ensures that your request is routed to the server that is best equipped to handle it, and it helps to prevent any single server from being overwhelmed. This is the key to ensure that users have a buffer-free experience and the platform remains fast and responsive even during peak times. The second example is Instagram. Let's say Instagram has millions of users scrolling and refreshing their feed simultaneously. Without reverse proxy, their backend server would be constantly bombarded with requests, leading to slow load time or even crash. Reverse proxy help distribute these incoming requests evenly across multiple servers, ensures that user feed load quickly and reliably. They also help with caching, so all that frequently accessed content like a popular post or a story does not need to be retrieved from the backend server every single time. The third use case of reverse proxies is in cloud services like AWS, Google Cloud, and Azure. These platforms manage traffic for millions of websites and applications. Reverse proxies help them handle incoming requests, manage traffic, and ensure that their services remain available and secure. Additionally, reverse proxies are crucial in protecting these cloud services from security threats by filtering incoming traffic and preventing attacks like DDoS attacks from reaching the backend servers. In all of these scenarios, reverse proxies are the invisible workhorses that keep the system running smoothly. They ensure that traffic is distributed efficiently and prevent overloads and just add an extra layer of security. So it's clear that reverse proxies are not just theoretical tools, they are used by some of the biggest platforms in the world to keep their services running reliably at a massive scale. So at last, we will summarize the key point that we have covered so far so you can walk away with a clear understanding of reverse proxies and their role in backend systems. All right, so let's take a moment to summarize the key points that we have covered so far about reverse proxy. First and foremost, Reverse proxies act as intermediary between client and backend server. Instead of allowing direct communication between the two, the reverse proxy manages all incoming requests, forward them to the appropriate backend server, and then returns the response to the client. This setup has several key advantages. One of the most important role of a reverse proxy is load balancing, and with a reverse proxy, incoming request can be distributed across multiple backend server, ensuring that no single server is overwhelmed. This is especially important for high traffic websites and applications like Netflix and Instagram, where millions of users are making requests simultaneously. Another critical function is security. So reverse proxies help protect backend server from directly exposure to the internet. Without a reverse proxy, your servers are vulnerable to attacks like DDoS attacks, where attackers can flood the server with requests to crash the system. This reverse proxy basically act as a shield, absorb these attacks, and filter traffic before it reaches the backend server. Finally, we can say that reverse proxy also improve performance through caching. They can store copies of frequently requested data so that when multiple users request the same content, the reverse proxy can serve it from its own cache instead of going back to the backend server every time. This reduces the load on the backend server and speed up the response time for users. So in conclusion, reverse proxies are essential for ensuring that large web applications are not only fast but also secure and scalable. By handling load distribution, ensuring that backend server, and improving performance, they make it possible for companies like Netflix and Instagram and major cloud service providers to operate efficiently at scale. Thank you so much for sticking around till the end of this video. I hope now you have a clear understanding of reverse proxy and just how important they are in keeping the web fast, secure, and scalable. If you found the video helpful, please give it a thumbs up, and it really helps the channel grow and reach more people who can benefit from this content. If you haven't already, subscribe to Preptain YouTube channel and tap on the notification bell so that you are always up to date with our latest videos. Your support means the world to us, and it helps us continue bringing you valuable content. We also have an amazing community over Telegram where we post the latest job openings and opportunities, internships, and exclusive tips. You can join us by following the link in the bio of this YouTube channel. Once again, I am Sahib Kumar, and I will see you soon with some more videos on backend engineering and beyond. Stay tuned, and there is a lot more to come.